Hi, everyone. We're going to be starting in about 1 minute. All right, let's get started. Hello and welcome to the Internet of Water Coalition webinar series. I am Faith Sternlieb, Associate Director for Engagement for the Internet of Water at the Center for Geospatial Solutions at the Lincoln Institute of Land Policy. Today, I am very pleased to introduce my colleague, Emily Wiggins, who is a Senior Analyst with the Center for Geospatial Solutions at the Lincoln Institute of Land Policy. So my close colleague. Yes, we are hosting our own material on our own webinar series, but we thought we would take advantage of both the venue and the timing to share the inner machinations of one of our core technologies, as we hope to engage all of you at one level or another to participate in its continued development. So before we get started, I'd just like to cover a couple of housekeeping items. We are recording the webinar today. So the recording and slides will be available on the IOW Internet of Water YouTube channel about a week after the webinar. So if you would like to refer back to anything you heard in today's webinar, or if you'd like to share this webinar with friends or colleagues, you'll be able to do that. We'll also be taking questions throughout the webinar. So if you have a question at any point, please drop it in the Q&A. We're not going to be using the chat for questions. And we will go through the questions after the presentation, one at a time. If you have any technical issues, please do use the chat for those. So the chat for technical issues, not for questions, and we'll try to get that fixed as soon as possible. So now on to the main event. I am pleased to welcome Emily Wiggins, Senior Analyst at IOW. Her presentation is on the Internet of Water's flagship technology, Geoconnex, and how this revolutionary water data specific search index links disjointed water data with structured metadata, and enabling seamless organization and discovery of information by theme and locations. So I will leave it to you, Emily, to get us started.
Great, thanks so much, Faith. So today, as Faith said, we're going to be covering Geoconnex 101. I wanted to point out that although you may have heard previously from my colleagues on various aspects of the Internet of Water, today is going to be on Geoconnex 101. And if there is a question, like Faith said, we will do our best to answer them. And I am thankful for my colleague, Ben Webb, who is also here today. He's our software developer. So if there's something I can't get you an answer on, I'm sure Ben can. So let's go ahead and get started. So first, I'm going to give a little bit of an introduction to CGS. So what is CGS? The Center for Geospatial Solutions was founded in 2020 by the Lincoln Institute for Land Policy to expand the use of advanced geospatial technology for land and water conservation. You will probably hear me refer to it as CGS a couple of times. I'll try to go easy on the acronyms, but I'm referring to the Center for Geospatial Solutions. So we're using geospatial tools and technologies to help our partners and clients address pressing issues facing the world, like climate change related issues and many others. By founding CGS, Lincoln took action to make open data more accessible so decision makers can act collaboratively, knowing they're working with the best information possible. We help many public and private organizations, including nonprofits, businesses, governments, large and small, to work on the most pressing and complex issues to accelerate their positive impact in North America. So our work is really in these four main realms. We meet our partners where you may be and provide a variety of services, from high-level strategic advising to supplementing your existing staff or helping to lead your organizational technical efforts. So as you'll see, Geoconnex fits nicely in a couple of these areas. Definitely environmental data modernization, certainly land and water management, sustainable infrastructure development, and definitely data-driven policy making. So how does exactly CGS fit in with the Internet of Water Coalition? Though the Internet of Water actually began back at Duke University, in March 2022, CGS and the Internet of Water Coalition formally joined forces to steward the next phase of their impact. We've also been graciously financially supported by USGS and work collaboratively with their staff. In its new role as the Internet of Water Service Center, the Center for Geospatial Solutions focuses on scaling the adoption of Internet of Water technologies and services. And both CGS and IOW are focused on broad environmental data modernization, making it a great mutual fit for everyone. By furthering the digital infrastructure necessary for the Internet of Water, CGS is helping to transform the water data landscape while serving as an implementation support partner for many organizations. And you can see some of those listed below, as I mentioned. So this work is continuing to be carried out in collaboration with the Internet of Water Steering Committee and IOW members. So now we're going to get into this real meat of the presentation here with the actual challenges and why we need a Geoconnex. So as many of you certainly must know by your interest today, our water future demands data-driven, real-time, and accurate decision-making. There is so much public water data available, but it's collected by different public, private, state, federal agencies and organizations and more for different purposes at different scales and scattered across multiple platforms with different standards, naming conventions, and the like. As a result, this data is often not very accessible or formatted in a way that's easy for scientists and other interested parties to use. Not talking to each other in the same way is directly impacting the overall impact that this data could have. We need to start considering water to be a shared resource and not letting it continue to be fragmented by a bunch of different classifications. We have heard that folks being graduate students, analysts and companies, nonprofits, anyone working in this realm. We've heard folks have spent up to 75% of their time looking for data, trying to find data from different sources, from all across the water data landscape, and only about a quarter of it actually working with the data and doing analysis that leads to the decision-making that these data provide. So we want that to be a lot different. We think and we know that Geoconnex can be the solution here, making the water data landscape as easy as Googling the weather is. Let's start talking about how Geoconnex is going to be our new shared language. So Geoconnex is a universal addressing system for our national hydrology landscape, which will enable water data discovery. You can think of it as a similar way to our addressing system, like street addresses. Geoconnex is spatially referenced, so that links it to real-world locations. And like street addresses, that enables an effective, fast global economy. So Geoconnex is going to do the same for our water data. We have things like 2-day shipping and the ability to map on Google Maps to get from one place to another. And so Geoconnex is going to do the same for hydrologic science. But we need to be smart and we need to be methodical about this because it's not easy. Take, for example, the Colorado River. When I say the Colorado River, you may be thinking about the one that flows through the Grand Canyon, but there's actually one in Texas too. So how do we know that we're both talking about the same gauge on the same Colorado River? How do we know when we put it in an address map that we're going to Main Street in the same place? So how that happens in Geoconnex is by helping water data producers describe data sets with a common vocabulary. Furthermore, we're referencing data in the same way, using what are called persistent identifiers that are both unique but also flexible. And that combination allows us to organize, link, connect, and access data both ourselves and for web crawlers like Google. So eventually the vision can be something like this image on the right, where if you want to Google water data for a place, it'll be as simple as Googling it. And you can figure out if that's stream flow that you're interested in, precipitation, water use data, etc. This is, I will note, a simplification, but it is Geoconnex 101 after all. So to untap the full potential of this Geoconnex system, we need water data that is spatially indexed, so mapped back to the real world locations where these data are collecting or related to, accessible data where anyone who's interested in it can get the data. You don't need any particular expertise. The data needs to be organized. So as I've mentioned, it needs to be structured properly. So both humans and machines can read it, topically organized so you can search for it easily and interlinked to each other. And then finally, perhaps the most important two, discoverable and usable. We need to be able to find this data easily so we're not spending 75% of our time looking for it, and others will be able to use the data that you're producing and researching and working on, and it needs to be usable. We need this data to be operational in scripted workflows and enabling automation, so we need to keep that in mind as well. So I'm going to talk now a little bit about where we've come from and where we're going in the future and where we are today, as you can see. So back in 2021, we really started with our infrastructure development, really building out the digital architecture of the Geoconnex system, including the back-end knowledge graph, supporting applications, and a very robust documentation portal. So we definitely began with the end in mind. Since then, we've worked on information population, where we've been adding data to the system and integrating key community and hydrologic reference features. You'll hear more about that soon. In 2023, we started with some pilot integrations where we were helping data providers publish their data to the Geoconnex system and adding capabilities to existing data publication software. Right now, we're actively working on designing what the front door of Geoconnex will look like. And what we mean by that is, how are people like all of you on the call going to be accessing this in the future? So we're working with stakeholders to figure out what exactly that will look like, keeping in mind there's a variety of user types who will benefit from this. We anticipate in fall 2024 an API launch, which will be more of a front door for what we're calling super user access. And then finally, in spring 2025, we anticipate a Geoconnex graphic user interface launch, or something that a merely casual user with no particular technical expertise will be able to easily interact with and use without any required technical knowledge. So let's talk about more where we are today. Today, Geoconnex is comprised of three main things: an open centralized knowledge base for all of that back-end data. That serves as our backbone, the master catalog of all the information that we've linked and cataloged. It also includes a suite of software and applications to assist organizations in indexing their data. It includes HubKit and PyGeo API, if you've perhaps heard of those through your research or previous webinars. And then, as I mentioned, a very robust documentation center to equip developers and other folks with technical expertise of the details behind the system. We've got it all documented very well. Again, kind of more of a super user resource, probably not something a merely curious user will be interacting with, but it's all there. So as much as you want to learn, you're welcome to it. Moving forward to how you can get started using Geoconnex. Again, as I mentioned, Geoconnex today. Over 8 million reference features in this knowledge graph background knowledge base that we have here. So if you want to get started using that, and we hope you will, I'm now going to go into a little bit of how you can do that and what's there for you. So the first thing I want to discuss are our reference features. We consider reference features to be the real world locations and areas across the US of common hydrologic and administrative boundaries. So those are things like hydraulic regions, the HUCs, if you've heard that term. Hydraulic unit code it stands for, and you could see the watersheds appearing on the right side of the screen. Each of those increasingly smaller goes up in size from 2, 4, 6, 8, 10. So all of the HUCs are in our system. Those are the watersheds. And then we have things like aquifers, stream gauges from the USGS, streams, which we more often refer to as main stems, state boundaries, counties and jurisdictions, Native American lands, census data, public water systems, so the areas where you may be getting your drinking water from, dams, and then in the future, please stay tuned, we have public land survey system data coming in. For those of you in the West, you may be familiar with PLSS, congressional districts, and then atmospheric deposition stations. So this data catalog as it is over 8 million features, and you can see we're actively adding to it still. So it's a great resource to start out with. In addition to the reference features, we also have provider data. So provider data are sources of water data that are cross-referenced with the community reference features that refer to other water data in the landscape. So at a national scale, we have the National Water Information System wells, we have hydropower sites, water quality portal stations from the EPA, and then NPDES, or the National Pollutant Discharge Elimination System. That's an EPA data set that tracks all of the places where pollutants are discharged in the US. Quasi data, that's the consortium for the advancement of hydrological science. And then the California Data Exchange Center gauges at a regional level, as well as New Mexico Water Data Initiative locations, and Water Data Exchange, or WADE, points of diversion. And again, as you can see, we're working furiously to add more, including Wyoming state gauges, as well as a great data set, including a lot of state gauges from the Pacific Northwest. So again, please stay tuned. We're adding to it every day, and it's already quite a lot of data, and we're looking forward to adding even more. As you can see, the image on the right of the Lake Tahoe region has a lot of data points on it. So getting into exploring Geoconnex today. As I present this slide, there will be a poll that will be coming up for you all, and we'd love for you to respond so we can gauge further outreach onto what type of materials would be best for our audience. So please self-identify if you're willing as to what kind of user you identify as, or perhaps what you hope to identify as. So first, as I've mentioned, we've had a curious user, someone who is interested perhaps in what water data is available upstream or downstream of a certain location. You don't need any technical skills to fit the bill here. You know, Santa Claus could be a curious user. For that, today, we're going to be going over the river runner visualization that we have, as well as our web application. Additionally, we have a savvy user. So that we consider someone like me, a GIS user who's perhaps quite savvy with the QGIS or ArcGIS suite of software. Maybe you know some R or some Python, you're familiar with REST endpoints or OGC APIs. And then finally, as I've mentioned, a super user. So that to us is somebody who's more of a data scientist or an engineer, someone who's familiar with Python, Sparkle, or R. Maybe you're a higher level developer. And for those, we won't be covering as many materials today, but we do have some resources for you available as well. And I would definitely direct you to our documentation center, but we have existing tools to the form of OWS Lib and High River. So looking now particularly at what we have for the curious user. So we're now going to discuss, as I said, River Runner. And River Runner is nice because you can see a variety of data producers, and all that they have in common is that their data is along the same main stem. So you're going to see that they're producing data and publishing data on the same river. And Geoconnex is allowing this view of the river to be possible. It's allowing for the interoperability to see all of the data that you can find in the real world along this river. And we are excited that when there is a Geoconnex API anticipated next fall, we know that's when other perhaps super users will be able to build on further technology like River Runner. So let's take a look at River Runner. So this is something you can do today. Like I said, we'll be sharing all the links and resources. So you're seeing what a raindrop point clicked, and then the path of that raindrop as it flows down the river and eventually makes its way to the ocean. The green, yellow, and red points are the locations along the main stem that are associated with that main stem or stream that are registered in the Geoconnex system. So you're seeing those locations because of the linkages that are in the back end of the Geoconnex system. You can see we're going along and then it goes back out to the whole view. And maybe I'll let it go through one more time since it's such a nice visual. We love the 3D element. It really gives you a feel for where your water is coming from, perhaps if you're wondering where your drinking water may be coming from, or just if it's a storm, how pollution may be moving across the landscape, how high rainfall may be moving across the landscape. It's just a really good tool and a cool visual, and you can go from there with even more information as the system grows. So again, that is our tool, River Runner. I'm just going to let it finish up one more time. Great. All right, so the other tool that I mentioned for a curious user is our web application that's a map. So we have the link for this. Let's click in and get started. As you can see at the whole United States level, and it does include just a little bit of Alaska, but I promise it's there as well as Hawaii. A lot of information across the entire US, but it's kind of a lot. So we're just going to look at California, and even that level, there's a lot of data. You saw those points for just Lake Tahoe. So we're going to zoom in right here and take a closer look here. So as you can see, as you zoom in more data shows up. Don't think that you're missing any data. You do just have to zoom in a little bit, and it is so much. So let your internet browser have a minute if it's taking a minute to load. And then I think we'll look at the Salinas River here. So the Salinas River, when you click on it, has a nice little pop-up. And if we select the related gauge locations hyperlink, you'll actually be linked out to a dashboard. And this dashboard is running on the Geoconnex system such that when you click the river, you're able to see all of the gauges that appear along the river. So you're able to find out who is monitoring the river and just get a look for what's going on. Pretty, base level, just a couple clicks. Anybody could do that. Santa Claus could certainly do that. But kind of taking you all on a journey from a more curious user to a more savvy user now. If we click on the Geoconnex identifier hyperlink for more info, that takes you to this landing page. And effectively, this is a visual of kind of the back-end system for how Geoconnex is working. So this is still the main stem, 1830046 Salinas River. And you can kind of think of this page as street, back to our addressing system metaphor, where you're interested in finding out where a certain street is, you're interested in finding out where a certain river is. So let's say this is the Salinas River. The link in our Geoconnex system that corresponds with this as a web resource is here in red. And you can see That 1830046, that is its unique identifier. So we talked about how that's one of the ways that Geoconnex works. It's a unique identifier. No other river has this. The Colorado River and the Colorado River have two different ones of these. So now we're going to look at a particular gauge on the Salinas River, because generally, if you're going to put in an address to something, you're not going to address it to the whole street. So how would we get a particular address of a particular gauge? This would be more like a house in our previous address example. So here we're saying the Salinas River, and we're saying a particular gauge on the Salinas River. You can see that the main stem URI field is that same 1830046 that corresponds with the Salinas River, and our URL there is saying that we're specifically interested in a gauge feature. Another thing that Geoconnex allows us to do, much like the dashboard, is look at all of the gauges along the Salinas River. And I put this URL up so you could see from a maybe more curious to savvy user how we are functioning this backend, such that if you're scripting or if you're working in a repeatable way, you're able to call these things and how the system is built in a repeatable, understandable fashion so you can get the expected results that you want. So here we're saying we want all of the gauges on the Salinas River with this URL call. And then this is, like I said, the back end. One more time to look at the Salinas River here. What if we want to look at everything on the Salinas River? Eventually, much like the River Runner visualization, all of the water quality monitoring portal, the water quality portal monitoring points, all of a given state's gauges, anything that is going to be related to the hydrologic science of the United States, eventually we want it to be referenced in this back end as an array on the right side of this attribute table. So eventually that's how everything will be linked to each other. We're still building the system out. We need your help, but that's what we're moving towards, just to give you an idea. A couple of resources now, as promised, for the savvy user. Hopefully that got a couple of savvy users already thinking. So if you are a QGIS user, one of the easy things you can do is add http://reference.geoconnex.us to your WFS OGC API features. So that's just a way to link to your data, to link to our data on your computer if you're using QGIS, which is a mapping software that is open source. So if you add this WFS connection, you're going to be able to access all of those reference features. If you're an R user, all it takes is 4 lines of code, just 4, there they are, to start visualizing something like the hydraulic unit code 12, the watersheds at the level 12, this is level 2, but it's HUC 12 for the entire US. So we have, again, all those reference features are available to be ingested if you're an R user. And then again, with a focus on a more savvy user, I want to go back to the map. As a proud University of Vermont graduate, I wanted to show a little example of the Burlington, Vermont area. So here I have clicked a National Pollutant Discharge Elimination System point. So you can see here that we have, first of all, in the table of contents, if you right-click and do Show Item Details, you will go to this page, which will be familiar to many GIS users, and you have the link to the REST endpoint if that's how you choose to access data, highlighting that it is shared to everyone, so you should have no access issues. Or if perhaps you want to just look at it in a map on your own, you have that easy capability as well. And then again, back to this view I wanted to show. If you are more interested in what the data in the points themselves contain, we can click on the URI here. And this again takes us to a landing page for that point feature. And similarly to what I just showed with the main stems and the postcard sending to a particular address along the main stem, You can see this point also has attribute information associated with it. And again, trying to illustrate how all of these things are linked back to their original source. If we click this link, which corresponds to feature details, we can pull up the page for the EPA site that this point is related to, get things like safe drinking water reports or whatever the pollutant discharge report may have for that location. So now looking at an opportunity ahead, we know that better water management starts with better water data. And we need everyone in this community to participate. Federal, state, academia, nonprofits, everyone has a role to play to make your water data more discoverable, standardized, and interoperable. We're really thankful for the organizations, and I know some of you are on the call today, that have taken steps to contribute your data to the Geoconnex system, like Quasi, USGS, the New Mexico Water Data Initiative, California State Water Resources Control Board, EPA. There's probably more of you on the call. I apologize if I missed you, but what's great is it's working. We have a working product. It's already making a difference, and that's amazing, but it's only going to become more valuable as more data is added. So we would love for you to get in touch with anyone on our team if you want to know more, if you want to know more about how your data can be ingested into the Geoconnex system. We have helped many people and we look forward to helping you. But again, if you consider yourself perhaps a more savvy or super user, there's also a great variety of tools that are out there for you to do this on your own. So we really want to meet folks where they are and provide you with the tools to both see the value of the system as it is, whether it's just visualizing how the raindrops are falling and where the water data is being collected, or adding your own water data to the system so you can run reports and analyze things. Or if you really want to get into the JSON, LD, brains, and the code behind this, we make it all available for you. So with that, I think we can open it up for questions.
Wonderful. Emily, thank you so much for sharing the work that we've been doing at Internet of Water for, since 21 and actually since even before then. So as you all can see, this is a major undertaking and we have so many partners to thank for, your insights, your help, your guidance and direction. And so, we are not in this alone, as Emily alluded to. So we do have a few questions, and I would like to invite Ben Webb for you to please share your video. And Emily, I wonder if you can stop sharing your screen?
Sure.
Wonderful. And we will get to the Q&A. Thank you, Ben. Nice to see you. And Emily introduced you earlier, so I will just go right into questions. And so this first question, I'm curious to see what you both think, but wanted to direct it to Ben. Since you are working internationally, Ben, will this platform expand internationally?
Yeah, so I feel like the answer to that is yes and no. Geoconnex itself has its origins in the OGC Second Environmental Linked Features Interoperability Experiment, also known as SELFIE. And that actually involved geoconnex.us and geoconnex.ca as in Canada. So thinking about interoperability between the two countries. So in the realm that, there is more than enough work to do domestically, I think short term, our focus is trying to get geoconnex.us as populated as possible, but all of the tools we're using are open source and all of the ideas and softwares can be applied on a global scale. That just requires a lot more mobilization. So yes and no.
Thanks, Ben. And I will say that we currently we have our hands full with the states, working in the states, and that both with states individually and with the federal government in the U.S. And so we are focused our attention there. But as been mentioned, we do have connections globally, and we will work. It will take a lot of time and effort to scope out what that would look like. So we have our eye on it for sure. The next question for either one of you, whoever feels comfortable responding: how were the unique IDs chosen? Ben.
I'll let Ben take it.
So, I mean, really, it is up to each organization. So you'll notice in Geoconnex URIs, after the geoconnex.us, it then subdivides into a namespace. So, for instance, there are reference features that all have their own namespace. Internet of Water has their own namespace. USGS has their own namespace. The list goes on and on. And then beyond that, to identify individual features, it's really whatever the unique identifier is. So for the reference features, the identifier is geoconnex.us/ref/ the HUC unit. So HUC2/12, 12 being the hydrologic unit. Same thing, FIPS codes for states, counties, really whatever the unique identifier that is most commonly used.
I just want to say, great question. If you didn't quite follow that, that's totally okay. That's definitely a question that could be in Geoconnex 102, but happy to continue answering more general or more technical questions.
All right, on to the next question. And I just want to remind you, and I reminded you in chat, to please post your questions in the Q&A so we can get to those. And there is no bad question. We realized we just presented a lot of information, and we would love to dig into anything that we went over in the presentation. So the next question: how can citizen science data be integrated into and contribute to Geoconnex?
I'll take a stab at this, and then Ben, maybe I'll let you answer about some particular resources, maybe with HubKit. So the data that citizen science collects, and I'm actually going to use the term community science since it's a little more all-encompassing. Not everyone doing the science may be a citizen, so we like to be more inclusive and use the term community. Although I know citizen is more commonly used, but inclusivity matters. So community scientists do an amazing, essential job. I believe there is a 2014 maybe EPA report saying up to 70% of our nation's waters are unassessed, and a lot of that 70% are actually being assessed by local community science organizations. So depending on how you share your data, it would be great to chat with you or your organization about how that data is being shared. I've worked with organizations that have all their data in composition notebooks in a filing cabinet. So the first step would be to get that digitized. But I've also worked with organizations that maybe have a Google map with different points for their monitoring locations. Maybe you're using an Esri GIS product. There are definitely ways that you can do that. It kind of just depends on where you are. But the short answer is there's a way. Ben, do you want to speak to anything in regards to HubKit?
I'm not going to speak to HubKit so much as other parts of the Internet of Water Coalition. So the Internet of Water Coalition is actually co-led by 5 organizations: the Duke Nicholas Institute of the Environment, ourselves as the Lincoln Institute of Land Policy, and then 2 others that I think can really get into citizen science, which is the Water Data Collaborative. And the Water Data Collaborative is based out of the Potomac region and really focuses on a place for any participant who wants to publish their water data online to do so. And then I think the other important one to mention here is the Consortium of Universities Allied for the Hydrologic Science Incorporated, and that is academic science. And they have a tool called HydroShare where they encourage not quite citizen science, but PhD students, academic researchers to publish their data. And in that tool, you can index your data to Geoconnex as you are publishing it. And more research publications are requiring that included in the methods of your publication. So with the idea that if people are going to have to publish their research and data online, why not also index it to Geoconnex?
Great. I think the two of you covered that one well. So our next question is from Janine Finn. In our library collections, we have a lot of historic materials on California water history that includes stream flow measurements, etc. Is there a historical collection planned or in place for Geoconnex?
Ben, I'm going to let you take that one too.
Mm-hmm. Actually, I don't know what is in place. I think Ben's working on a link that's not working. So I'm just gonna fill in some time and space here. That's an excellent question. I know that there are, Colorado has an archive, water archives. There are a lot of certainly universities and actual states that do have historical data. I don't think we have anything at this time, but it's where you could like a historical section. But I'm guessing that you'd be able to certainly include water data as you would include current water data. So I'll say that for now, although we can get back to you on a more certain answer. And maybe Ben, I'm not sure if you were able to fix that link and have anything more to add on the historical water data question. Oh, we had a typo in the link. Okay.
Actually, I think the link was right, Martin. It looked like you may have had it wrong. Oh, it's the High River link, not the Geoconnex River Runner link. Never mind. Excuse me. I'll let Ben do that one.
Should we go to the next question? And if Ben has anything to add on the history question, we can come back to it. Thank you so much, Janine, for your question. And if we don't get back to it now, we will certainly get back to you on, a little bit more definitive answer. So for the next question, Ingo wants to know, how will users or organizations upload and update their water data? What will be the QA/QC procedures? Is that also for Ben, Emily?
Ben, you just went on mute. If you want to say something, go ahead. I'll let you start.
Yeah. So honestly, the way it works is a little bit like the way Google works currently, where everyone is publishing their own websites on their own. So Geoconnex is not necessarily going to be hosting all of that, and we are not going to necessarily be hosting that data. Part of the foundational issue with water data is that USGS, by mandate of law, has their own website for their own data, as does EPA, as do many state organizations. So the issue is, in fact, is that there's no way for asking organizations to go in and upload and update their data in one platform is impossible and unrealistic. And so it works in the same way Google does, where it uses structured data. And if the structured data is in a correct way, in the way that the rest of the semantic internet is able to communicate with each other, it will be ingested. So when they talk about search engine optimization, QA/QC and search engine optimization is that if your data is not in the correct format, people won't be able to find it. And if your data is in the correct format, people will be able to find it and will be able to use it. So that is how it works. So we're letting organizations publish their own data, and if their data is in the correct format in Geoconnex, it will be searchable, it will be indexable. If it's not, it will exist in the same silos that they exist right now.
Great, thank you, Ben. So I'm just going to get back to the historical question because we have another question on top of that. So Ben, if you're ready for this, the second question is related to the historical question in that is there a possibility to start to extract data from historical documents, literature in the future that is not explicitly added by the data provider? And if you remember the initial question, if you could address that as well.
Yeah, so actually a lot of the work that we've done thus far has been extracting data from PDFs. There's a large effort to do that and publish it online. As with historical data, Geoconnex really aims to improve data searchability and discoverability. So you would be able to say, I want to know everything about this river for as long as time, you know? And if you want to look at data just that is recent, that is real time, that could be a filter that could be put on how you're able to search Geoconnex. But Geoconnex, just like the rest of the internet, is really supposed to be an archive for everything. And it's about, you know, the geospatial existence of those rivers. So in the same way, yes, the goal is to make it so that, you know, if you as a data provider don't necessarily house all of the data yourself because you haven't existed since as long as the river has, and there's been other organizations collecting data. Historically, the goal is to make it so that all of that can exist in one ecosystem and communicate with one another. So you don't need to know all of the organizations downstream of you, even the ones that don't exist anymore, and know how to find their data. That is a process that is done automatically. That is the goal of Geoconnex itself.
Great. Thank you, Ben, for clarifying that. So we have a question on WASH, again, by Nicholas Dickinson, and I'm going to send this over to Kyle. I believe Kyle Onda, the director of the Internet of Water, is available at least by audio. The question is this: I'm interested in replicating Geoconnex in another area. So for those who don't know, WASH is water, sanitation, and hygiene. In other countries. Is there a simple guide or manual for the process we used and all of the components? And Kyle, if you are with us, you're on. And I'm not sure if he's having some technical difficulty, but Ben, do you want to take a stab at this?
Yeah, I can go ahead. I don't know if there's been a specific documentation of all of the software we have used, and that's actually something we're working on right now. So I would say reach out to us and we can start a longer conversation. But all the tools we're using are open source and available online freely. So
great. Hopefully, Nicholas, you'll follow up with us and we can for sure get you the information you're looking for, or at least answer your question in more detail. So another question here, can you please provide the best link for using these data in R?
Yeah, so R is not sure that there's a really best link, but we are going to be sharing the slides. So those 4 lines of code that I showed, you're going to be able to replicate that on your own. And then I would direct you to the SF package and the map view package. Those were the 2 that I was using just in that quick example. So that's map view and SF package.
Great. Thank you, Emily. We have another question. This is the final one, at least that's here for now. So please, if you have an additional question, there's no shortage of questions. Please type it in the Q&A. You see, we have a little bit more time. So this question, can you please provide or elaborate on the methods you used for data management? Do you follow any existing data management standards like OPC UA or ISO 8,000, or do you have your own method?
I'm gonna tag in Ben on this, but I will start in saying that I believe the answer to this is there's no specific built-in if you're talking like QA, QC here, it's on the provider's responsibility to provide data that is of good quality to such that they deem it to be or have a standard for it to be. But Ben, if you want to elaborate on that, go ahead.
Yeah, so to that, I would say we're looking more at web standards. So really, we are following Worldwide Web Consortium, or W3C, best practices for data publication, using RDF and OGC standards. So we're really sandwiching ourselves in standards more than data quality, as considering we are not necessarily the ones publishing the data. We're mostly looking to help others organize and publish their own data.
All right. Well, I think, oh, just in time. Just in time, we have another question. They're trickling in. For either of you, are data providers explicitly opting in to be included, or is any viable data being mined automatically?
I will say automatically is a little more generous than I would say, because the presumption there is not much data, I would say, that is perfect and ready and good to go, because it would already be in there. So we have mined some public data, and we've worked with some organizations to get their data in a mining way integrated. So it's not a matter of opting in, it's a collaborative effort. And just because your data is online doesn't mean we're going out and seeking to add it. Because that would still be a lot of work, and not all public data is ready to go in Geoconnex, which is why we have the resources and tools to format it so it can be. Ben, anything you want to add there?
I think you got pretty well to the meat of it. Yeah, I mean, the goal is, it is the same community contribution model that the internet is, where eventually you just put your website on the internet, and if you are doing it in the correct way, it will get discovered, it will get used, you'll receive a significantly higher click rate. But early on in the internet, just like early on in this process, it is right now a more involved process. And we are mining and trying to enrich the data in Geoconnex so that there is better reason to join, because if we're starting to get some snowball effect there, like Emily said. But yeah, the goal is that we're collaborating on this.
Excellent. Well, I want to thank you both so very much for your presentation, Emily, and for the Q&A, both of you. Thank you all for joining us for today's webinar. So my last thanks is to all of you for joining us, and hopefully for those of you who have contributed, and those of you who are interested in continuing to contribute and participate. Remember to be on the lookout for the recording in a week or so on the IOW YouTube channel. But if you have any questions in the meantime, feel free to reach out to me or to my colleagues directly, or to Internet of Water. Our email is internetofwater@lincoln.edu, regarding any questions you may have about the Internet of Water Coalition or the initiative or Geoconnex. And remember, these webinars are a platform to share your work and expertise across the Internet of Water community, and I would even open that up to the water data community. So if you or your organization have a webinar or idea, or would like to present your work, please let us know by emailing our team, and there it is. There is our email address, internetofwater@lincolninst.edu. Thank you so much for joining us today. Have a great day.